Dear learners, welcome to the another new lecture of Engineering Chemistry e-lecture series. In today's video, we will discuss the boiler troubles. In our previous video, we have already discussed one of the boiler trouble, that is scale and sludge formation. In today's video, we will going to discuss the boiler corrosion, caustic embrittlement and priming and foaming. All these three boiler troubles will be discussed in details, which includes the causes, disadvantages and prevention of these three boiler troubles. I will provide the link of one of the boiler trouble, scale and sludge formation, which we have discussed earlier in our previous video. So you can find the link of that boiler trouble in the description box. So let us begin with the boiler trouble, boiler corrosion. Boiler corrosion is the decay of boiler material due to the chemical or electrochemical reaction induced by certain chemicals on its surface. So basically, the boiler corrosion is the boiler trouble which is induced by three types of chemical present in the boiler feed water. And what are these chemicals? These chemicals included dissolved oxygen in the boiler feed water, dissolved carbon dioxide in the boiler feed water and dissolved mineral acids in the boiler feed water. That means due to the presence of dissolved oxygen, dissolved carbon dioxide and dissolved mineral acids, these boiler material becomes brittle or becomes very weak due to the chemical or electrochemical reaction induced by these kind of chemicals onto the boiler surface. So this is the basically the corrosion problem initiated by the presence of oxygen, carbon dioxide and mineral acids in the boiler feed water. So first we are going to discuss the boiler corrosion due to the presence of dissolved oxygen in the boiler feed water. So first question comes to our mind that what is the source of dissolved oxygen in the boiler feed water? That means from where the oxygen get involved in this boiler feed water. So we know that at the room temperature the boiler feed water contains approximately 8 ppm of dissolved oxygen always. So the basic source of dissolved oxygen in boiler feed water are directly from the atmosphere, that is 8 ppm oxygen always remain in the boiler feed water. Secondly, as dissolved oxygen of the water. So second question comes to our mind that why this corrosion creates why this oxygen creates corrosion problem. So in boiler, oxygen is introduced through the raw water supply. As water is heated, the dissolved oxygen is get free and reacts with the iron of boiler, and at high temperature conditions it forms the iron oxide rust. So basically we know that in boiler water is converted into steam, and for this steam conversion we have to increase the temperature of boiler feed water. So when we increase the temperature of boiler feed water for steam generation, due to this increased temperature the dissolved oxygen is now get free due to the higher temperature. Now this free oxygen reacts with the iron of the boiler material at high temperature and ultimately forms the iron rust. In this way the dissolved oxygen which get free at higher temperature dissolves slowly the iron of the boiler material and converted it into the iron rust. So in this way the oxygen causes the boiler corrosion. Now how can we remove this oxygen from the boiler feed water? So there are two methods to remove the oxygen, dissolved oxygen from the water, that is mechanical method and second one is the chemical method. The mechanical method for removal of oxygen from boiler feed water includes use of mechanical de-aeration chamber. This de-aeration chamber is based on the Henry's law and Dalton's law. According to Henry's law, the the solubility of any gas is directly proportional to its pressure, and according to Dalton's law, solubility of any gas is inversely proportional to its temperature. That means as we increases the pressure, solubility increases, and as we decreases the temperature, solubility increases. So what we want to do here, we want to remove oxygen from the boiler feed water. That means we have to decrease the solubility of oxygen in the water. So to decrease the solubility of oxygen in water, what condition we have to maintain in this mechanical deaeration chamber? We have to maintain the low pressure and high temperature. Why? Because of the Henry's law and of the Dalton's law, we know that the temperature is inversely proportional to the solubility and pressure is directly proportional to the solubility. So if we decrease the pressure, lowering the pressure, the solubility decreases, and if we increase the temperature, the solubility will be decreases. So to decrease the solubility of oxygen in the water, we have to maintain the low pressure and high temperature condition in the mechanical deaeration chamber. So this is the mechanical deaeration chamber. To create the low pressure, we connected it to the vacuum pump. So this vacuum pump creates vacuum, that means pressure inside this mechanical chamber decreases. And to increase the temperature, we are using the steam jacket, which continuously increases the temperature of this mechanical deaeration chamber. So due to this, in this mechanical deaeration chamber, which type of condition are maintained? This maintained the low pressure condition as well as the high temperature condition. Both of these conditions are favorable to decrease the solubility of the gas or of the oxygen into the boiler feed water. So in this way, now when we pour the water into the mechanical deaeration chamber, in this chamber low pressure and high temperature is maintained. So in this chamber, solubility of oxygen decreases, and this oxygen now no more remain as the dissolved form, and this oxygen can exit to the vacuum pump from here. So in this way, oxygen can be removed from the boiler feed water. Now, chemical method for removal of oxygen from boiler feed water, which includes addition of some chemicals like sodium sulfite, hydrazine and sodium sulfite in the boiler feed water. All of these chemicals combine with oxygen and consumes the oxygen, and hence decreases the concentration of oxygen in the water. For example, the sodium sulfite reacts with oxygen, convert it into the sodium sulfate. So it consumes the dissolved oxygen present in the boiler feed water. Hence, oxygen concentration decreases in the boiler feed water. Similarly, this hydrazine reacts with oxygen to form nitrogen and hydrogen. So this hydrazine also consumes the oxygen and decreases the oxygen concentration in the boiler feed water. Similarly, the sodium sulfite also consumes the oxygen and converted this dissolved oxygen into the form of sodium sulfate. So in this way, any one of the chemical we can use to decrease the concentration of oxygen in the boiler feed water. So in this way, we can remove the oxygen from boiler feed water and prevent the boiler from the corrosion. Now the second reason for the boiler corrosion is the dissolved carbon dioxide. So what are the sources of dissolved carbon dioxide in water? First, it is as the dissolved carbon dioxide in water. Secondly, the carbon dioxide formed by decomposition of various type of bicarbonate salts like calcium bicarbonate. When decomposes, it also generates the carbon dioxide. So during the boiling process, as the temperature increases, some of the bicarbonates decomposes, and due to their decomposition, the carbon dioxide concentration increases in the boiler feed water. So second question comes to our mind, that how this carbon dioxide creates boiler corrosion. So answer of this question is that in presence of water, carbon dioxide forms carbonic acid, which has the corrosive effect to the boiler material. At higher temperatures, carbon dioxide reacts with the boiler feed water and forms the carbonic acid, and we know that the acids are highly corrosive for the boiler material. So in this way, the carbon dioxide creates the boiler corrosion. Now, how can we remove carbon dioxide from the boiler feed water? Similar to the oxygen, here two methods are to remove the carbon dioxide. First is the mechanical method, second one is the chemical method. Mechanical method is the same as we are using in the removal of carbon dioxide. Same mechanical deaeration chamber uses. In this condition, low pressure and high temperature conditions are maintained, and due to these conditions, the dissolved CO2 removes through the vacuum pump in this way. So from the bottom side, we can remove the deaerated water. So this mechanical deaeration chambers remove the oxygen as well as carbon dioxide from the boiler feed water. The chemical method for removal of carbon dioxide includes addition of calculated amount of ammonium hydroxide in the boiler feed water. This ammonium hydroxide reacts with the dissolved carbon dioxide present in the water and forms the ammonium carbonate. So when ammonium hydroxide is added to boiler feed water, it consumes the carbon dioxide present in the water. In this way, it reduces the concentration of dissolved oxygen in the boiler feed water. Now, the third cause of the boiler corrosion is the presence of mineral acids. The sources of mineral acid in water are acidic industrial waste and the magnesium salts like the magnesium chloride. If we are using the boiler feed water which included acidic industrial waste, so it already contains the mineral acids, or the water which contains the magnesium salts. So during the boiling process, this magnesium chlorides or magnesium salts reacts with water and form the corresponding mineral acid. Like here, the magnesium chloride generates the hydrochloric acid during the boiling in the boiler feed water. So the free HCl present in the boiler feed water reacts with the boiler material just like iron to form the iron hydroxide, which ultimately converted into the iron rust. In this way, when iron comes into the contact, iron, that means the boiler body, boiler material, comes into contact with the HCl, it gets dissolved in the form of iron chloride, which in turn converted into the iron hydroxide after reacting with the water. Ultimately, this iron hydroxide converted into the iron rust in the boiler feed water. So in this way, slowly the boiler material degraded. So this is the main cause of the boiler corrosion. So how can we remove or how can we prevent the corrosion due to the mineral acids? So to prevent this type of corrosion, we can remove the mineral acids from the boiler feed water. For this, some calculated amount of alkaline substances can be added to neutralize the acids present in the boiler feed water. So basically, the acids can be neutralized with the bases, or in this way we can prevent the boiler corrosion due to the mineral acids. So now we are understanding that due to the presence of oxygen, carbon dioxide and mineral acids, boiler material becomes weak, and this is the cause of the boiler corrosion. So what are the disadvantages of this boiler corrosion? There are three main disadvantages. First, it reduces the life of the boiler. The increased cost of maintenance, because we have to replace the boiler material time to time, because due to corrosion it becomes exhausted. Third one, due to the corrosion, the leakage of the joints and rivets may take place, which may create the problem. So these are the disadvantages of boiler corrosion. Now, moving towards the next boiler trouble, that is the caustic embrittlement. Caustic embrittlement is the phenomena during which the boiler material becomes brittle due to the accumulation of caustic substances in the boiler. So this is particularly the boiler trouble which is caused by the presence of the caustic substances in the boiler. Generally, it takes place in the high pressure boiler due to the presence of highly alkaline water. Now question comes to our mind that how boiler water becomes alkaline. So in scale formation prevention method, we have discussed the external method of the scale formation prevention, in which I have discussed that to prevent the scale formation externally, we can add water softening agents, and for this purpose we may add the soda in the boiler feed water, which reacts the hardness causing salts and water becomes soft. So if during the external treatment excessive soda is added, soda, what is soda? Soda is sodium carbonate. So if excessive sodium carbonate is used, it remains in the boiler itself. So when such type of water is used, for which water softening is done with the help of the sodium carbonate. So in some conditions, the excessive sodium carbonate or the remaining sodium carbonate existing in the boiler feed water itself. So during the boiling process of water or the steam generation process, this sodium carbonate reacts with water and generates the sodium hydroxide, which is the alkali substance. So due to the formation of NaOH, the boiler water becomes alkaline. So this is the main cause of the caustic embrittlement. So due to the presence of sodium hydroxide in boiler feed water, the boiler feed water continuously alkaline. So when this slightly alkaline water flows into the minor cracks present in the boiler feed water, if such type of cracks are present in boiler feed water, the NaOH containing water flows into these minor cracks. Now what condition develops here? Here two conditions are developing. First, the metal surface which is in contact with this area, NaOH containing water, and second one is this bulk surface where the water is in contact with the metal. So in this small area, when water evaporates, the concentration of NaOH continuously increases. Due to the small area and higher temperature, evaporation process takes place at faster rate in this cracks area. So now the metal surface is now here becomes chemically non-uniform. Why? Because in this crevices area, in this hair cracks area, concentration of NaOH is higher, while in this bulk area, remaining area of the boiler, concentration of NaOH is lower. So in this way, this metal surface becomes chemically non-uniform. One is the cracks area which is in contact with the concentrated NaOH. One is the bulk metal surface area which is in contact with the dilute NaOH. So due to this chemical non-uniformity, now corrosion of the metal takes place. At the higher concentration of NaOH, this NaOH dissolves the iron slowly and convert it into the sodium ferroate. So in this inner area, iron get dissolved in the water in the form of sodium metaferroate, and this sodium metaferroate reacts with the water and forms the iron rust. In this reaction also there is the formation of NaOH. So the water present in the hair cracks or the crevices of the boiler surface now become more alkaline due to the excessive generation of NaOH in this reaction. So in this way, slowly the inner boiler material becomes weak due to the inner corrosion of the boiler material. So now question comes, so how we can prevent the caustic embrittlement in the boiler feed water? So the root cause of this caustic embrittlement is the presence of the sodium carbonate in the boiler feed water. So to prevent the caustic embrittlement, first thing we can do, that we can use the sodium phosphate for water softening in place of the sodium carbonate. So if excessive sodium phosphate would be there in the boiler feed water, this cannot create the NaOH and water will not be the alkaline in this case. Secondly, we can prevent the entry of NaOH into the crevices or the minute hair crack area in the boiler material surface by adding tannin or lignin as additive to the boiler feed water, which prevents the entry of NaOH to the minute hair cracks. Or we can use the sodium sulfate to the boiler water, which also prevents the entry of NaOH into the minute crevices. So in this way we can prevent the caustic embrittlement of the boiler material. Now the next boiler trouble is the priming. What is priming? When steam is formed at a high speed in the boiler, some droplets of water carried along with the steam. This phenomena, that is the presence of water in steam, is called priming. What are the causes of priming? High velocity of steam. Second, the presence of suspended and dissolved impurities in water. Very high water level in the boiler. Faulty boiler design and the sudden ebullition. These are the causes of the priming. That means these are the causes due to which wet steam is formed. So how we can prevent the priming? There are some methods or some steps through which we can avoid the priming. First, avoiding rapid changes in the steam rate. That means steam generation should be carried out at the uniform rate. Second, keeping the water level lower in the boiler so that the water cannot be mixed with the steam. Third one, the good boiler design should be used. Fourth, by using water having no suspended impurities, we can avoid the priming, and by changing the boiler water from time to time so that concentration of salts cannot be increases and there would not be the sludge formation in the boiler. So in this way we can avoid the priming. Next is the foaming boiler trouble. It is the formation of continuous foams of bubbles in the boiler due to the presence of oil and alkali substances in the boiler feed water. So why these alkali and oily substances creates foam in the water? This is the main cause of the foaming. But foaming is caused by the presence of oil and alkali substances in the boiler feed water, because actually oil and alkali reacts to form soaps, which greatly reduces the surface tension of water and thus cause the foaming. Because we know that when soap is dissolved in water, it creates the foam, it forms the lather. So that is why when oil and alkali impurities are present in the boiler feed water, it forms the soap and the soap forms the foam. That is why foaming existed. Now, how can we minimize the foaming? First, by adding anti-foaming chemicals in the boiler feed water. Second, addition of castor oil, which is spread on the surface of water and neutralizes the reduction in the surface tension. Third, removing oil or soap from the water. Fourth, blowdown operations should be done at appropriate timing. What are the blowdown operations? We discussed it in the sludge formation prevention method. Blowdown operation is the removal of concentrated water of the boiler from the fresh water, so that the concentration of salt cannot be increases in the boiler feed water. So these are the methods to prevent the foaming. Now Why we are discussing priming and foaming as boiler trouble? Because these have several disadvantages. So let us discuss the disadvantages of priming and foaming. Priming is the wet steam formation. So wet steam carries dissolved salts of boiler water with it to the superheater or turbine blades, where these are deposited after the evaporation of water. So the deposited salt hinders the flow of steam and hence reduces the efficiency of the turbine. Second, the presence of water droplets in the steam may lead to the corrosion in the steam inlet ends of the superheater, which also decreases the efficiency. So these are the disadvantages of priming. And due to the foaming, the height of the water column cannot be judged properly. Thereby, it makes the maintenance of the boiler pressure, proper boiler pressure maintenance is difficult in such case. So these are the disadvantages of priming and foaming. So in today's video, we have discussed the various type of boiler troubles, which includes boiler corrosion, caustic embrittlement, priming and foaming. Now, today's learning check. Please read the question displaying on your screen and think for that. A boiler system is experiencing unexpected failures in the form of intergranular cracks near riveted joints. A chemical analysis of the boiler water shows a high concentration of sodium hydroxide. What is the most likely cause of this failure? Yes, you are correct. The caustic embrittlement is the cause of this failure, because we can see here the accumulation of NaOH in this water. So this creates a presence of NaOH creates which type of boiler trouble? Caustic embrittlement. So that's all for the today's video. To unlock more awesome content, you can hit and like button and subscribe my channel. Thank you.